In this video, I will show how to identify a function before finding derivative. Recall that the idea of derivative is rate of change. Before we learn how to find derivative of functions, what types of function is given to differentiate? So that leads to types of functions. Types of function. There is what is called constant function, polynomial function, fractional power function, another name for fractional power function is radical function, rational function, functions. Another name for rational function is called fractional functions. There is another function called exponential function, logarithm functions. We also have the trigonometric function. All the sevens are function, but the technique to differentiate it are not the same. Think this function as all written tools: red pen, blue pen, black pen, pencil. They are all written materials, but each has different uses depending on the paper and style. All these are functions. To take derivative of each of these functions, it uses a different technique. So what are the natures of these seven functions? Nature of f of x is the same thing as y. F of x is the same thing as y. The general form of constant functions. Constant functions. The general form of constant function is f of x equals to y is the same thing as c, where c is in real numbers. So we call it a constant function because there is no variable x or anything that will be changing attaching to the functions. This is the general form. Example in particular, f of x equals to 2. 2 is in real number. F of x equals to 13. 13 is in real number. All these are called constant functions. In this case, you can also have f of x equals to minus 15. Minus 15 is coming from real number and it is a constant function. For all x in real number, the function is always a single function. Single. It remains unchanged. Change x when x is equals to 10. F of x is always 13. When x is equals to 15, f of x is always 13. Polynomial function. How does polynomial functions look like? Polynomial function, the general form for polynomial function is f of x, or the same thing as p of x as a polynomial function, is an x to the power of n plus an x to the power of n plus an minus 1 x to the power of n minus 1 plus an minus 2 x to the power of n minus 2 plus on and on plus a1 x to the power of 1 plus a naught. This is general. Particular example, given f of x equals to 2x plus 1. In this case, the highest power of x is 1. We say this is a polynomial of degree 1. So in this case, this is to compare it with this, f of x is equals to 2x when x to the power of 1, this is it, a1x plus a0, where a1 is equals to 2, a0 is equals to 1 from this case. So another example of polynomial function, given f of x which is the same thing as y to be 2x. This is a polynomial function, f of x equals to a1x plus a0. Compare, because this is x to the power of 1, so the polynomial starts from here to the last. So what is what is a? a1 is equals to 2. The coefficient of x is what is a1, because this is x to the power of 1. a0, the term without x, there is no time without x here, so it's going to be 0. It's a polynomial function. Given a function f of x equals to y equals to x to the power of 3 plus 2x squared plus x. Compare with the general form of polynomial function when n is 3. So this is the general form, f of x equals to a3 x to the power of 3 plus a2 when it reduces x to the power of 2 plus when this reduce a1 x to the power of 1 plus when it reduce a0 reduce with 1 a0 x to the power of 0 is 1. So you don't need to write it. In this case, what is the coefficient of when n is 3? a3 is 1, the coefficient of x to the power of 3. What is the coefficient of what when n is 2? a2 is 2. What is a1? Which term with what is equals to 1? What is a0? There is no term in this polynomial that has no x, so it's going to be 0. This is the polynomial function. If they also give the polynomial function to be equals to f of x equals to x to the power of 4 plus x squared, it's a polynomial function. The highest power of x here is equals to 4. This is a polynomial of degree 4. Compare it with the general form of polynomial, f of x is the same thing as what? a4 is started from 4, the highest power, x to the power of 4, plus when it reduced with 1, a3 x to the power of 3, plus when it reduced with 1, a2 x to the power of 2, plus a1 x to the power of 1, plus a0. What is a4? The coefficient of when x to the power of 4. This is equals to 1. What is a3? The coefficient of when x has power 3 here. There is no term that has x to the power of 3 here, so it's going to be 0. What is a2? a2 is when we have term to the power of 2. Yes, is 1 here. Then what is a1? Term with x. There is no term with x here. It's going to be 0. a0, term without x. There is no term without x here. It's going to be 0. So all these functions are called polynomial functions. Fractional power functions. Fractional power functions. What does these fractional power functions look like? The general form for fractional power function is f of x to the same thing as y, x to the power of m over n. M, n are in integers. Remember that natural numbers is inside set of integers. The set of integers is inside rational numbers. Rational numbers is inside real numbers. And irrational number is inside real number. So when they say m, n is coming from, remember that this is coming from integers. Remember that integers are sets of negative numbers from the left, -2, -1, 0, 1, 2, 3, on and on, close with curly brackets. So example of this function is what? F of x equals to y, x to the power of 3 over 2. In this case, m is equals to 3, n is equals to 2, equals to x to the power of 3 over 2. This is the same thing as square root of x to the power of 3 because x 1 over 2 is same thing as square root of x. Given f of x equals to x to the power of minus 1 over 2. In this case, the same thing as x to the power of what? Minus 1 over 2. In this case, m is equals to minus 1, n is equals to 2. Given f of x equals to x to the power, f of x is same thing as 1 over x to the power of 1 over 2, which is equals to 1 over square root of x. X can never be 0 because if x is 0, the denominator will be undefined. Given f of x to t over 1 over 3, this is the same thing as the cube root of t. Same thing as cube root of t. In this case, m is equals to 1, n is equals to 3. Of z equals to y equals to z is going to be z because here is z. So here is z. Here is 1 over 4. This is same thing as what? Fourth root of z. This is fourth root of z function. The rational functions. The same thing as what? Ratios of polynomials. So how does these functions look like? The general form of this rational function is f of x equals to g of x over h of x. In this case, g of x is a polynomial, h of x can also be polynomial. G of x can be trigonometric function, h of x can also be full. But if it is a polynomial function, example, if it is a polynomial function 2x plus 1 over x minus 1, in this case, g of x is equals to 2x plus 1 and h of x is equals to x minus 1. Given f of x to be x to the power of 4 plus 2x squared plus 1 over 3x squared minus x plus 1. In this case, g of x is what? X to the power of 4 plus 2x squared plus 1. H of x is 3x squared minus x plus 1. Rational function are of this form. Exponential function. The exponential function also have its general form. They are not the same with fractional functions. The exponential functions, the general form for exponential function is f of x, the same thing as y, is equals to a to the power of x. In this case, a is a number positive. A must not be 1 because if a is 1, the function will go back to constant function. So when a is bigger than 0 and it's not equals to 1, it's going to be a exponential function. Example of this function is f of x equals to 2 to the power of x. In this case, 2 is bigger than 0 and 2 is not equals to 1. F of x equals to 5 to the power of x. In this case, 5 is bigger than 0 and 5 is not equals to 1. Natural exponential function. In this case, the natural exponential function is when you have e to the power of x or e to the power of x squared. This is what is called the natural functions. In this case, you can also have f of t. F of t equals to exponential t. These are called the natural functions. How does these functions look like? These functions are the inverse of exponential functions. The general form for this logarithm function is f of x equals to the log x to base a. In this case, y is same thing as log x to base e. Example of this function is y equals to log x to base 2. In this case, you can also have it as f of x equals to log x to base 2. It can also be f of x equals to log x squared plus x plus 1 to base 2, all logarithm function. We also have what is called the natural logarithm functions. In this case, f of x is of the general form when e equals to a is going to be the log of x to base e, or we can also have f of x log x squared minus 1 to base e. The trigonometry functions. The trigonometry functions are the functions that are sine, cosine. The trigonometry studies triangle, treat the angle as what? A variable. So on unit circle, that is a circle that have radius 1. On unit cycle, the full name sine. The shortcut is called sine. The cosine is called cos. The tangent is called tan. The cotangent is called cot. Then the secant is called sec. The cosecant is called cosec. But for what? For hyperbolic function, the hyperbolic sign is called sinh. The hyperbolic cos is called cos. The hyperbolic tangent, the hyperbolic cotangent, the hyperbolic secant, the hyperbolic cosecant with h. But for trigonometry functions, sin x, cos x, tan x is same thing as sin x over cos x. In this case, it's not a fractional function of polynomial. This is a fractional function of trig. So this is what we call the cot x. This is the same thing as cos x over sin x. The reciprocal of this is called cot x. The same thing as 1 over tan x. The secant x. In this case, is 1 over cos x. The same thing as sec x. The cosecant x, which is 1 over sin x. The same thing as what? Cosec x. This is the same thing as 1 over sin x. And this is going to be a what? Fractional trigonometry function in this particular case. For hyperbolic, it's going to be sin x, hyperbolic cos x, hyperbolic sin x, hyperbolic cos x, hyperbolic tan x. Example, given f of x equals to sin x plus sec x. This is the same thing as sin x plus 1 over cos x. Trigonometry function. Given f of x to be cot x, this is the same thing as cos x over sin x, or same thing as 1 over tan x. there is division, it's going to be a fractional function. Constant, this is a constant function. The down is trigonometry function. Constant function and trigonometry function is in the ratio. This is going to be fractional trigonometry functions. The first is constant function. Constant function, the general form for constant function is of the form f of x equals to c. For all x in real number, c is also in real number. Example of f of x equals to 2, 2 is in real number. For all x in real number, the constant function is unchanged. The second function is called the polynomial function. Polynomial functions are functions that are of the form f of x equals to p of x, an x to the power of n minus 1 plus an minus 2 x to the power of n minus 2 plus on and on plus a1 x to the power of 1 plus a naught. So the polynomial function is p of x equals to f of x equals to an x to the power of n plus an minus 1 x to the power of n minus 1 plus an minus 2 x to the power of n minus 2 plus a1 x to the power of 1 plus a naught. Example of this polynomial function is f of x equals to x squared plus 1, f of x equals to x to the power of 4 minus 3x plus 1. This is a polynomial of degree 2, polynomial of degree 4. Another function is called the fractional power functions. The fractional power functions, the general form for it is of the form f of x equals to y equals to x to the power of m over n. M, n is in integers. Example of this function is x to the power of 2 over 3. In this case, m is equals to 2, n is equals to 3. Another function is called the fractional functions. The general form for fractional functions is f of x equals to q of x over h of x. The q of x can be polynomial. The h of x can also be polynomial, but h of x must not be 0. F of x, example of this function is f of x is equals to 2x minus 1 over x plus 1. X must not be equals to minus 1 in this case. This is a fractional polynomial function. F of x equals to tan x. This is the same thing as sine x over cos x. In this case, this is fractional trigonometry functions. There is another function called the exponential functions. The general form for these exponential functions is of the form f of x equals to a to the power of x. A must be bigger than 0. A is not equals to 1. The function called the exponential function. This function has the general form of the form f of x equals to a to the power of x. A is bigger than 0. A is not equals to 1. When a is equals to 1, it's going to be a constant function. 1 to the power of x is going to be 1 and it's going to be a constant function. Example of this function is equals to 2 to the power of x. In this case, 2 is bigger than 0 and a equals to 2 is not equals to 1. You can also have as f of x equals to y equals to 42 to the power of x. 42 is bigger than 0. A is equals to 42, which is not equals to 1. This is called the exponential function. The other one is called f of x equals to exponential x or f of x equals to exponential x square. We can also have f of x equals to exponential x plus 1. In this case, is called the exponential function. This is called the natural exponential function. For this number, f of x can also be 2 or 2 also be given as f of x to be 16 to the power of 2x plus 1. It is also called exponential function. Exponential e is called the natural exponential function. Another function called the logarithm functions. These functions has the general form as f of x equals to the log x to base a, or f of x equals to log x to base e. This is called the natural logarithm function. This is the same thing as ln x. When e equals to a is called the natural logarithmic functions. So example of this function is f of x is equals to log x to base 2. When e is equals to a, we have f of x equals to log x to e. You can also have f of x to be log x squared plus 1 to base a. In this case, it can be 2 here or any number. This is a logarithm function. F of x equals to log x to base 2. When e is equals to a, we have f of x equals to log x to base e. This is the same thing as ln x. F of x equals to log x squared plus 1 to base 2 is called logarithm function. But when f of x equals to log x squared plus 1 to base e, this is the same thing as ln x squared plus 1. This is also called the natural logarithm functions.